Inverse function reverses another function. Okay? It's the opposite. It's the anti-function. Now, when you think of a function, now I have graphs up here so you can look at graphs, but you think of a function is something like y equals 3x plus 2. Functions take in x values, you apply some operations to them. Like 3x plus 2 would multiply by 3 and then add 2. And they tell you an answer. An inverse function works in the opposite way. It takes your answer that you got out, applies some operations, and tells you where you started. Think about it as like opposite directions, okay? Now, a couple things to look at. You can graph functions on your calculator, and you can visually see that they're inverses without checking anything because they're reflections over this y equals x line. And sometimes that's tough to see, but it's also a really easy check because we have Desmos. If a question asks you, are these two functions inverses? Well, you can graph them real fast. And once you see a couple that are inverses, you can really see it jump off the page that that's absolutely an inverse. You can see this one that looks like it's twisted. The blue line goes here, green line's here. It's absolutely been flipped over that 45-degree angle line, okay? And we'll get further into this when we look at tables and everything else. But I wanted to start with the activity that's right here. So let's try that. So finding an inverse. So we're going to literally start this like directions. So directions from A.L. Brown to Carson. Everybody know what Carson is? School down the road, right? And now these directions may not be right now because they've redone all the roads from here to there, but they were when we made this. So it says directions to Carson. You leave A.L. Brown and you turn left onto East 1st Street. Then you turn left onto Highway 29. Drive down the road for a while. Turn right onto 52, right onto Crest Venture Road, which is that road that leads you straight into Carson. And then you drive down into the woods and you're at Carson. How would you get back? If you were sitting in your car now in Carson's parking lot and you realized you forgot your cleats and you needed to turn around and get back here really fast and you took the fastest way there, how would you use those directions to get back? What would your first step be? If you had to do it? Where would we start? Well, the first thing I would do if I'm already at Carson, right? These directions are read from A.L. Brown to Carson, meaning we started up here at A.L. Brown and we arrived at Carson. To go backwards, where would we start? We would start at Carson and work which way? We'd work back up to get back to A.L. Brown. So we would need to do this first, right? But what do I need to do to that step? Do I turn right onto Crest Venture to get out? No, which way do I turn? I'd turn left. I've got to turn left to go out because I turned right to get in. That means it's going to be the opposite direction to get back out of that parking lot. And then I follow Crest Venture down, and then what am I going to hit next? I'm going to hit Highway 52. Am I going to turn right on Highway 52? No, I'm going to turn left on this, right? And we can keep this pattern going. We're actually working from the bottom of this to the top. We turn right because we turned left when we headed there, so we have to go opposite those directions. We turn right to head backwards. When you think of this in directions, this right here, those are inverse. We inverted these. We did them backwards, but we had to make sure we did what to each step. We also needed to flip around each step and find its opposite. We needed to take the directions that were in each one of them, and we needed to flip them around and make them their opposites. So we got these directions because we used opposite order, opposite operations. We don't think of it as operations because directions, turn left, turn right, that comes very natural, but those are opposite operations. This is the same method that we use to find inverse functions. We got to think, well, our function starts with an x and arrives at a y, and we do things in a certain order to get there. If I want to go backwards, I start with the y, I do the operations in opposite order, but I need to apply their inverses. So let's talk about inverses real fast of specific functions. What's the opposite of adding? Subtracting. What's the opposite of subtracting? Adding, because those are inverses, right? What's the opposite of dividing? Multiply, and the opposite of multiply is divide. The one that gets us more often than not, and these come in groups, right? This is a group. This one groups together. Those are inverse operations. What is the opposite of squaring something? Like if you had x squared, yeah, well, I'll just say it. The opposite is square root. So that means that the opposite of the square root is squaring something. So you've got to know your inverse operations to make this work as you go through. So that should help us a little bit. Let's actually kind of continue this. Let's take this and let's do this with numbers now. So starting with the number, I want you to take a number, write a number down on a piece of paper. Add 5 to it and write the answer next to it. Then divide the result by 3. Then subtract 4 and then double it. And so if I did this, let's say I started with 2, right? The next step would be 2 turned into, I added 5, right? And I got 7. And then I divided it by 3, which is going to get yucky now. And I got 7/3, right? And I subtracted 4. And 7/3 minus 4 is 1 2/3, and it's negative. And then I doubled it, which is times 2. I'm not worried about these numbers in between, but let's find the final answer. And we got to our end, and this is, let's see, 2, 3 1/3. And just the fact it makes that harder, I picked a poor number to start with. I don't want you to focus on the numbers in between this. I want you to think this is like A.L. Brown. And our answer was like Carson. These were my directions. How do I get back to where I started? What am I going to undo first? I'm going to undo this times 2. What's the opposite of multiplying by 2? Dividing by 2. Then I have to undo this minus 4, so that means I'll need to add 4. I'll need to undo this divide by 3, which means I'll need to multiply by 3. You getting the idea? If you took this and you followed these steps, you would actually get an answer of 2. You would undo all these steps. It's still opposite order, opposite operation. I like this diagram. It's called an arrow diagram, as you list what you do forward and what you do back. But you could also list these out at steps. When we went backward, we would half the number, which is divide by 2. Then we would add the 4, multiply the 3, subtract the 5, and then we would arrive back at the number that we started with. Since I didn't pick a really nice number to start with, it'd make it a little tougher, but I promise you that it would work. So what we want to do, though, is I want to actually create a function for the forward equation. I want to see its equation, because we're going to be dealing with equations more. So f of x is these steps. So what did we do to x? So we started with a number. Anytime you see start with a number, Pick a number, any number. That's what X means. When we write X on our paper, we're saying pick a number, any number. And the first thing we're going to do to that X is we're going to add 5. And I want to do that first, so I'm going to put it in parentheses. And then we're going to clean this up afterwards. What did I do after that for this forward function? I divided the result by 3. So I did the first one, I did the second one. Now I subtract 4 from that thing. That's my third step. And then I double it, which is like multiplying by 2, and that's my last step. And I get this really ugly, messy looking thing with a whole bunch of parentheses that you're going to want to clean up. Now, when you go to clean this up, you start in the inside and you figure out, do I really need the parentheses to make these operations happen in that order? So let's look at our operations. The first thing we wanted to do is we wanted to add 5. What's after that plus 5? After that plus 5, the next step is divide by 3. Would we normally add before we divided? No, and man, you got to think this comes down to PEMDAS, right? Normally we would divide before we add it. How do we change the order? We put parentheses around the operation we want first. So since we want this operation first and this one second, and that's not the correct order of operations, that means this X plus 5 needs to stay in parentheses. And then I wouldn't write that divide that way, I'd put it down here. Now we have to do this same process each time to determine whether we really needed those parentheses or not. So now we are at the divide. Would we normally divide and then subtract? And when we answer that question, we're looking here. So divide is right here, subtract is right here. We always work this from the top to the bottom. So yes, normally we would divide and then subtract. So do I really need parentheses there? I don't. This one would just be -4. The order of operations preserves the fact that you'll divide before you subtract. Then you work to the next one, subtraction. Do we normally subtract and then multiply? No. So that means if I want to make sure this subtraction happens, I need to take everything that's already written and put it instead of parentheses and then write the times 2. Now we put it right here, but normally where would you put that 2? Do you put it at the end, even though it's your last operation? No. When you clean this up and you make it look right, you would put this up here in the front. And that would be our function, our forward function. In given words, sometimes it's tough to work your way there. Go through looking at each individual operation and what it's followed by to determine whether you need parentheses, okay? That's how you help clean this up and make it look better. We're gonna do the same thing for the backwards function, okay? And we're calling this one g of x. Now, this is what they called it here, but this is also important right here. The function is called the inverse function of f of x, and its notation, it gets that little -1 on f of x. So when you write this, you'll see this little -1 there. The reason this is important is if you see a function with a little -1 written there and they give you an answer, they're telling you that that is an inverse of something. Okay, so we need to be sure that we use that notation often so we get used to seeing it. But we're gonna tackle this the same way. We're gonna start here, and our inverse is down here. So we're gonna work backwards. So we still start with x, and the first operation was divide by 2. Then, and you know, I'm gonna do this without parentheses this time, and then we'll determine whether we need them or not. So the first thing I wanted was divide, then plus, then times, then minus. So let's take our little cursor like we had here. I'll just draw another one. and determine whether we need parentheses around the stuff before it. So I have a divide. Would I normally divide and then add? That's okay. That's right. Divide and then add. That's the way this comes normally. Now, would you normally write that division with that symbol? Nope. So what that means is you would go x divided by 2 and then write the plus 4. That's going to happen in the order, in the correct order that I want, because that is the order of operations for that. You divide, then you add. Let's move down and look at the next one. Will we normally add and then multiply? Or do we, no, we normally multiply and then add. So anytime we get one that's out of order, we need to put parentheses around everything we've written before we write that next operation. So this is where our times 3 would go. We normally wouldn't write it at the end. It would go up here in the front. Do we normally multiply and then subtract? That's the correct order of operations. So that means I just need to put a minus 5 here. And this is my inverse function, guys. This is f of negative 1 of x. If we went to Desmos and we graph both of those in Desmos, which I think we'll do, you'll see that they're reflections of each other over that y equals x line. So let's actually look at it. I'm going to plug them both in. So one of them was 2x to the 5th divided by 3 minus 4. X plus 5, right? Make sure I get the right equation. X plus 5 divided by 3. That's my first one. 2x plus 5 divided by 3 minus 4. 2x plus 5 divided by 3 minus 4. This is not in the right spot. It is. It's nice with Desmos because it has the proper formatting to make it look like what you would write on your paper. Plugging these things into your handheld calculator is tough. So we get a line. Now, if we come back and we do the second one, 3x divided by 2 plus 4 minus 5. It's not, because these are both lines, it's not as obvious. But if I put this on here, if I go y equals x, I put this right down the middle, I'm going to make it dotted. The blue line is, you can see they're the same distance apart. You can actually see that they're reflections of each other. And with lines, it's not quite as apparent and jumping out. But it's an easy way, especially after you do your algebra, to go back in and plug it in. If you see this type of feature, then you know that this has worked. I'm going to type in 2 that I know. Close. Oh, I can't see it. I'm too far away. Let's not worry about those. We'll come back. We'll see that later. But that's one way you can use the graph to aid you. Once you've done your equations, you can look, and if you were off, say you put the parentheses out here instead of in here, that one doesn't jump out quite as far as I wanted. If you mess them up, you can tell, because we'll start getting ones that aren't just lines, okay? But they get a little bit tougher to see. All right, back to where we were. Let's try this again. This one has power in it. So let's list the operations being done to find the function. I like listing them in that arrow diagram. If you want to make a list and then like directions and then write it the other way, that's fine. This is kind of a side work process. So as we go through, we're going to put a number in for X. What are we going to do to that number first? How many operations do we have? Let's start there. We have a multiply, we have a power, and we have a subtraction. And there's no parentheses anywhere. So we can use our order of operations to help us figure out what order this would go in. I'm going to do that power first, that exponent first. So that means the power of 2 is the first operation. Then I'm left with a multiplication and a subtraction. Based on order of operations, I'm going to multiply by 2. And then the only thing I'm left with is the subtract 5. That's what I would do with the X to figure out the output. And this is the little up character thing. I didn't want to write the X in there. So that's what's being done with this. We're going to, and if we listed this out, we're going to square X, multiply by 2, and subtract 5. That's if I listed it out as a list, right? I like this because I think it's a little bit shorter and it helps me with the inverse. I want to start here and work the opposite way because I want to find the inverse. That's what the second part of this. And it says list the operations and give the inverse. So operations, how do I undo a -5? Well, I add because it's subtract, and I'm going to add the same number. How do I undo this multiplication? I'm going to divide, and it's by the same number. And this is the one that we tend to struggle with more. This is a squaring. To undo a square, we've got to take the square root. So if we list the operations, we're going to add 5. Divide by 2. And then we are going to square root. I'm showing you both of them. The arrow diagram also lists the operations. Now let's use our previous process and figure out what the actual equation of the inverse would be. So if we had our X, first thing we're going to do is add 5. Then we are going to divide by 2. And then we're going to square root. And that's where this gets a little bit weird. Since square root's at the end, I'm going to square root everything that's done, meaning all of this stuff is going to be under a square root. So let's talk about parentheses on this step before we deal with the square root. I want to add and then divide. Do I need parentheses to do that? I do, because that's not the correct order of operations. So when I do this, I know I need this X plus 5 and then the divide by 2. Now the last step was square root. Whenever you see square root in your list, all of this stuff is going to be under the square root symbol. And you just need to figure out parentheses on the stuff before it. So that means since I already figured out where I need parentheses, I just put a square root over it, all of it, and that will be that inverse. List the steps, work backwards, check your order of operations. One thing I did want to point out though, there is another way to find these, and I wanted to show you before we move on. I wanted you to understand where we were going with this, but there's an algebraic way to do this. So we started with f of x equals 2x squared minus 5, right? And I want to find the inverse. There's an algebraic way to do this. We now understand what it's doing. It's undoing the function. So the way you can do this algebraically, let's put the y in here so we see it. So first step here, flip these two variables. because we want our x to become our y and our y to become our x. So I'm going to write x out here and y out here. Now I want to solve and get y by itself. So now we're doing algebra. How do I get y by itself? Meaning I want this to be solved so it's just a y equals. So that means I need to get rid of the 5, right? So I get rid of the 5 by adding. That'll make it cancel. That's x plus 5. Now I need to get rid of this multiplication, meaning I can divide. That'll cancel. And because I want to do this division first, I should probably put parentheses around that to be safe. So this is x plus 5 over 2, and this was y squared. How do I get rid of the square? I square root both sides. Meaning that when I get down and I solve for y, look what we ended up with that we just wrote down. The square root of x plus 5 over 2. When we flip those variables and solve for y, we just algebraically found the inverse function. It matches what we just found right over here.